Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Combined Science Physics Paper 2 Higher Tier from 2024. Question number 2 is on the topic of forces. Figure 2 shows an Olympic gymnast performing a flow routine. The floor contains springs. When the gymnast lands on the floor, the force compresses the springs in the floor. When a spring is compressed, the elastic potential energy of the spring increases. Explain why compressing the spring in the floor helps the gymnast to jump higher. Use ideas about energy in the spring. So let's say when the gymnast is landed on the spring, it's compressed. So that's the elastic potential energy increases. So what happens when the gymnast moves away from the floor? That elastic potential energy, I label that as EE, is going to get converted to kinetic energy and then ultimately to gravitational potential energy. Explain why compressing the spring in the floor helps the gymnast to jump higher. That elastic potential energy is being converted to kinetic energy or higher kinetic energy and then to GPE. Remember, GPE equals the mass, gravitational field, and the height. So if you increase the gravitational potential energy, you're going to increase the height as well. So here's the answer. As a spring decompresses, the elastic potential energy of the spring decreases. As the gymnast leaves the floor, the kinetic energy of the gymnast increases, or the gravitational potential energy of the gymnast increases. That should give you the 3 marks, right? So when it decompresses, the elastic potential energy decreases. As the gymnast leaves the floor, kinetic energy of the gymnast increases and gravitational potential energy increases. So it's only for 2 marks. Or you could explain this in terms of force and work done. You could say, as the spring decompresses, the spring exerts a force on the gymnast. So work is done on the gymnast. When you're doing work done, remember work done equals the force multiplied by the distance moved. So the higher the work done, the more the work done. Sorry, distance moved. 2.2. When the gymnast lands on the floor, one of the springs compresses by 1.2 centimeters. The spring constant is 8,500 Newton per meter. Calculate the elastic potential energy stored in the spring. So how do you calculate? Using the compression. Now compression and extension, you can treat it like the same. So elastic potential energy EE equals half K E squared. K is the spring constant, E is the extension, or you could here use it as the compression. Now before we put the value of 1.2, it needs to be converted to meters. So 1.2 divided by 100 equals 0.012 meters. So 0.5, that's the half, times 8,500 times 0.012, and that should be squared. So let's bring the calculator. So we've got 0.5 times 8,500 times in brackets. So let's use the bracket function. 0.012 close bracket and that should give us 0.612. So the answer is 0.612. Now, because it's elastic potential, it's still energy, the unit is joules. A student investigated a spring with a different spring constant. When masses are added to the spring, it compresses. The student measured the compression of the spring for different masses. Describe how the compression of the spring could be determined. Right? So here you don't have any masses here, so you could actually measure the length of the spring and you can call that the original length. And when you add the mass is obviously the spring is obviously going to get compressed, and you can find the new length, right? That's the original length, and you take away the new length from the original length and you will find the compression. How do you write that? You could write it in the form of an equation, right? Or in words, either way it's fine. Measure the original length of the spring and the compressed length of the spring using a ruler. So compression equals original length minus the compressed length. Or you could write down, calculate or measure the weight of the masses on the spring. That will be the force, and use the equation E equals, or the extension equals, the force divided by the spring constant. Now for that you need to know the spring constant here. So the first answer is actually a better way of writing it down, right? Work out the length with the force and without the force and work out the difference. Explain why the investigation should be done on the laboratory floor rather than on a table. For simple safety reasons, because the masses that they seem to be using are large masses. So if it's done on the lab floor, it'll be safer. If it's done on the table, it could roll off and fall and you could hurt yourself. So that should be okay to actually state. Masses could fall off the spring because it's not going to be stable. So it's less likely to cause injury or damage if it's done on the floor. Next question. Figure 4 shows the results. So you got the force in newtons here from 0 to 400, the scale on the y-axis, and the x-axis is the compression in meters, and it looks like it's a linear relationship because it's a straight line, and if you were to extend it, I think it might actually go through 0. The spring constant is the gradient of the line of best fit shown on figure 4. Determine the value change in y on figure 4, and we can look at the next question, the change in x as well. So the change in y, right? So let's figure out how much is one box. Now that's 100 and that's 10 boxes. That's easy. 100 divided by 10 gives you 10 newtons. So each box is 10 newtons. So you can see this is on the 8th box. That means it's 80 newton. And this is 300, 330, 330 newtons. So 330 minus 80 will give me 240 newton. That's my delta y. And the x, this is 0.01. If I divide that by 10, I'll get 0.001. So that's on the 8th. That's 0.01. And this is 0.05. 51, 52. Yeah. So This is 0.052. We'll rewrite that again properly. So I got 0.052 take away minus 0.01. That gives me 0.042. So 240 and 0.042. Did I make a mistake? Let me double check the first value. I'm feeding it 330 minus 80. That's 250. There was a mistake. Okay. Right, so that's not 240. That's 250. So 250, you don't need to show you're working for 1 mark. So 0.042 is the change in X value. Determine the spring constant of the spring. Use the answers from above. Give your answer to 3 significant figures. So how would you find the spring constant? They've stated that the spring constant is the gradient of the line. The gradient is the y over the x value, or delta y over delta x. So y is 250 divided by, right, y over x is 250 divided by 0.042. Okay, let's look at the calculator instead of making mistakes. So 250 divided by 0.042, that gives me what, that 5,952. 5,952.38. And that in 3 significant figures will be 5,950. That brings us to the end of question number 2, and I will see you in question number